Greetings, math fans. All right, so we're going to start Chapter 5, and Chapter 5 is called Trig Identities. Okay. All right, so first thing we're going to talk about is we're going to basically review what some of these different trig identities that we already know are. Okay, we know sine of theta, we know cosine of theta, we know tangent of theta. Okay, and tangent of theta we can write as sine of theta over cosine of theta. Right, so that's an identity. And we also know cosecant of theta is 1 over sine of theta, and secant of theta is 1 over cosine of theta. And of course, cotangent of theta is 1 over tangent of theta, or in terms of sines and cosines, it's cosine of theta over sine of theta. Okay? So those are really the trig functions that you guys know already. So let me kind of start out with an example here. If I give you, so this is given, cosecant of theta is equal to negative 5/2, and I tell you it's in quadrant 3. The angle resides in quadrant 3. Okay, and then my question is find the other 5 trig identities. All right. So, a couple things we have to do. You got to guys remember, sine is y over r. Okay. We're going to cosecant, so cosecant is going to be r over y. And remember that negative right here, the negative really goes to the bottom, right? So I would say r is equal to 5, y is equal to negative 2, because you can't have a negative radius. And then we need to find the other functions. We need to find x. So don't you guys agree it's x squared equals r squared minus negative 2 squared? And then take the square root of both sides. So you basically get x is equal to the square root of 25 minus 4 is square root of 21. Okay, is that right? Did everybody agree with that? Boo! What's wrong with it? Okay, it's in the wrong quadrant. Think about it, guys. That's why I give you this extra information here, quadrant 3, because we're over here. And x and y are both positive, or both negative here, right? So that's important. X is negative root 21. Okay, so now if I actually do all my trig functions, we already knew sine. Sine was actually pretty easy because it's just the reciprocal of cosecant. So it's negative 2/5. And then cosine of theta is going to be x over r. So it's going to be negative root 21 over 5. And then tangent of theta is going to be our good friend, the yax. Okay, so it's going to be y over x, which is negative 2 over negative root 21. Of course, you simplify it and rationalize it, you get 2 root 21 over 21. And I don't have to do cosecant because that was given. And secant of theta is equal to just the reciprocal, so it's negative 5 over root 21, which is negative 5 root 21 over 21. And last is cotangent of theta, which is the evil distant cousin, the soy. So it's negative root 21 over negative 2, which is root 21 over 2. Okay? That's pretty easy, right? Pretty mellow stuff. So it's just using kind of the basic identities that we learned. All right. So let's move on here. All these other functions, if we draw our unit circle, based on the unit circle, we have x squared plus y squared equals r squared. Okay, this is called, or these are called, Pythagorean identities. All right, and they're all based on the Pythagorean theorem: x squared plus y squared equals r squared. So the first one I'm going to do is if I tell you guys cosine of theta is equal to x over r, and I cross multiply, I get x equals r cosine of theta. Okay, and then I can say sine of theta is equal to y over r. So I cross multiply and I get y is equal to r sine of theta. Then I substitute that into the x squared plus y squared equals r squared. So r squared cosine squared of theta plus r squared sine squared of theta equals r squared. Okay, and what can I do? I can actually divide the whole thing by r squared, right? I know I'm losing a root, but that's not really what I'm looking for. I'm looking for the theta, not the r, so it's not really losing a root. And I wind up getting, I'm going to rewrite this because this is the way I think it's good to know it. Sine squared of theta plus cosine squared of theta is equal to 1. Okay, math fans, this is really important. I'm going to put a red box around it, and if you have red pens, you should be putting a red box around it too. Alright, so that's our first identity. Sine squared plus cosine squared equals 1. Alright, next one is, again, it's going to be using x squared plus y squared equals r squared. And so let's do secant of theta is equal to r over x, and tangent of theta is equal to y over x, the ox. Okay, and so for this one, if I cross multiply, I get r equals x secant of theta, and for this one I cross multiply and I get y equals x tangent of theta. So let's substitute those values in. I have nothing for x squared, so I'm going to write x squared plus y squared, which is x squared tangent squared of theta, is equal to r squared, which is x squared secant squared of theta. Okay, and divide everything by x squared, and I get 1 plus tangent of theta, tangent squared of theta, is equal to secant squared of theta. Okay, and then, again, the way I'd like to have you learn, it doesn't really matter. Tangent squared plus 1 equals secant squared of theta. So this is another red boxer. Okay, in terms of tangent and secant. And let's do our last one here. We have, so actually I'm going to write this out here again. X squared plus y squared equals r squared. I have cosecant of theta is equal to r over y, and cotangent of theta is equal to the equal distant cousin x over y. Alright, and you cross multiply for each of these guys, so we get r equals y cosecant of theta, and this one is x equals y cotangent of theta. Okay, we substitute that in there, so it's substitute for x squared, so it's going to be y squared cotangent squared of theta plus y squared is equal to r squared, which is y squared cosecant squared of theta. Okay, now they all have y, so we're going to divide everything by y squared. And I get cotangent squared of theta plus 1 equals cosecant squared of theta. Alright, this, of course, gets another red box. So we got 3 equations here. 3 equations that are going to be super important that we're going to be using quite a bit. So I'm just going to write them out again because I think they're just important to, so I can just talk about them all in one place here. So we have sine squared of theta plus cosine squared of theta equals 1. And then we have tangent squared of theta plus 1 equals secant squared of theta. And then we have cotangent squared of theta plus 1 equals cosecant squared of theta. Okay, so those are our Pythagorean identities. Now, again, we a couple things I want to mention here. First of all, notice these terms are squared. Terms are squared. Okay, that's huge. So please don't tell me sine of theta plus cosine of theta equals 1. Boo! Does not equal. Okay, so all those terms have to be squared. And I don't know. There's a lot of goofy ways to remember this. this one you just kind of know, sine squared plus cosine squared equals 1. That's huge. This next one, remember the tangent goes with the secant and the co goes with the co. So cotangent goes with the cosecant, the regular tangent goes with the regular secant. Okay? And then which one gets the 1? The tangent and the cotangent get the extra 1 because that's the yax and the xoi. Okay? Those are, and they always get a bonus point, so that's why they always get +1. So the 1 always goes with them, and they're equal to the non-bonus guys. All right? I know it's a little hokey, but maybe sometimes people kind of remember hokiness when you are you're doing your quiz or test. All right? So those are the Pythagorean identities. Let us talk now about negative angle identities. Okay, negative angle identities. I know it's kind of a negative topic, so we'll try to be a little upbeat here. I'm going to show you 3 different negative angle identities. So let me draw a picture here first. And I'm going to put pi over 6 here. I'm going to put 5 pi over 6 here. I'm going to put, as opposed to putting it all the way around, I'm just going to say negative pi over 6. And this is negative 5 pi over 6. Okay? And let's talk about what the signs are here. First of all, this is for sine. Okay? That's for sine, trig function. And the sign SIGN is going to be positive here, negative here, negative here. And remember that that's from our old famous guy, all students take calculus. So sine is positive in the top part, first 2 quadrants, and negative in the second 2 quadrants, the bottom ones. Okay. What I want to do is actually take the sine of a lot of these values. So if I take the sine of pi over 6, I will get 1/2. If I take the sine of negative pi over 6, well, isn't that what the I mean, you could look at it as 11 pi over 6, but isn't the reference angle pi over 6? Whenever you see a 6 in the bottom, I mean that's the beauty of radians. I could say pi over 23,172,164 pi over 4. You know that the reference angle is pi over 4. That's the beauty of it. Okay. So pi over 6, the reference angle is pi over 6. What's the sine of pi over 6? 1/2. And of course, then it's negative 1/2. Okay. Sine of pi over 6. Oh, again, the reference angle is still pi over 6. What's sine of pi over 6? 1/2. So of course we're in the positive quadrant, so it's also 1/2, positive 1/2. I know this is negative 5 pi over 6. I can also write this as 7 pi over 6, where I do coterminal and add 12 pi over 6. So the reference angle is still pi over 6, and the so that's going to be 1/2. All right, and then of course it's going to be negative 1/2 because it's in the third quadrant. All right, so we have some values here, positive and negative, and I want to make a little thought here. Sine of theta, do you guys agree it's y over r? And sine of negative theta, so that's why this is positive, it's y over r. And sine of negative theta, isn't the y value negative? Isn't negative y over r? Okay? So therefore I can make I can declare that the sine of a negative angle is equal to negative sine of the positive angle. Alright, that's kind of what that says, because again we can take any example here, and if you have a negative angle, okay, if you have a negative angle, the answer is negative of that. Okay, a negative angle, the answer is negative of the positive value. That's what I'm looking at. It's negative of this positive value. So this belongs in a red box. That's sine of theta is equal, sine of negative theta is equal to sine, negative sine of theta. Alright, let's do cosine. So this is going to be cosine. And we can put a couple different things here. First of all, let's do the same numbers. Pi over 6, 5 pi over 6, negative 5 pi over 6, and negative pi over 6. Okay? And let's talk about where cosine is positive and negative. Well, it's positive here, it's negative here, it's negative here, and it's positive here, right? All students take calculus. So positive in the first and the fourth quadrant. Alright, so let's take the cosine of some of these values. Cosine of pi over 6, you guys agree? It is root 3 over 2. The cosine of 5 pi over 6, well, the reference angle is pi over 6, so it's root 3 over 2, but it's negative. We're in the second quadrant. So it's negative root 3 over 2. Same reference angle, pi over 6, so that's also negative root 3 over 2. And it's positive here. So reference angle is still pi over 6, so it's positive root 3 over 2. So this one kind of looks a little bit different. This one's saying cosine of theta is equal to x over r. And if I go cosine of negative theta, so do you guys agree? Here's positive, let me do the highlighter. Here's positive theta, and here is negative theta. So how does that change? The cosine of negative pi over 6 and the cosine of positive pi over 6, aren't they the same value? Well, sure are. So I can just say it's cosine of the positive of that angle. Same thing goes with this side here, math fans. Cosine of a positive angle gives me a negative value, and cosine of a negative angle gives me that exact same value. So that's why the cosine of a negative angle is the same thing as cosine of a positive angle. Alright, so that belongs in a red box. Okay, last one. Okay, now let's do tangent. And we're just going to make it a little bit easier. We're going to use pi over 4. Just to make it a little bit easier. So this is going to be 3 pi over 4. This is going to be negative pi over 4. This is going to be negative 3 pi over 4. Okay, so tangents, positive here, it's negative here, positive here, and negative here. All students take calculus. Alright, so let's do tangent of positive pi over 4 is 1. What's tangent of negative pi over 4? It's negative 1, because we're in the second quadrant, or in the fourth quadrant. So tangent of 3 pi over 4, well, again, the reference angle is pi over 4, so I know it's 1 or negative 1. Of course, it's negative 1 because of the negative here. And the last thing, the reference angle is pi over 4, so it's 1, and it's positive here, so this is positive 1. Okay, so this actually is kind of has the same idea of sine. Okay, because remember, it switched. If I go from here to here, you switch signs. Same thing from here to here, right? You switch signs. So I can really say the tangent of theta is equal to the y over x, the yax. And then if I go to a negative value, tangent of negative theta, that's equal to the y is negative, right? Negative y over x. So it flips the sign. Okay, so I can say tangent of theta, actually tangent of negative theta, is equal to negative tangent of theta. So if the angle is negative, it's the same thing as taking the tangent of the positive angle and putting a negative in front of it. So this again, math fans, is going to have a red box around it. Okay? So let's summarize what we have here. We have sine of negative theta equals negative sine of theta. We have cosine of negative theta equals positive cosine of theta. We have tangent of negative theta equals negative tangent of theta. Okay, so these two go negative. So if it's a negative angle, then it's a negative sine or negative tangent. This one stays positive, so cosine of a negative angle, it maintains its positive. So the way I have you guys remember that, the way cosine goes to positive, I always say cos is pos. Cos is pos. It's a great cheer. Cos is pos. Cos is pos. Okay. Anyway, those are our identities. So those are our negative angle identities. These four guys right here, negative angle identities. All right. So let's use some of this information now that we talk about Pythagorean identities, we talk about negative angle identities, we talk about just reciprocal identities with secant, cosecant, and cotangent. So now what we're going to do is we're going to use the identities to rewrite an equivalent expression using only sine and cosine. And then what you're going to do, you're going to simplify it. Okay, that's huge. You got to simplify it. Okay, so basically the final answer can be in sine, cosine, tangent, secant, cosecant, and cotangent. Okay, it really can be at all those values. A couple things here that you kind of need to remember. We're trying to eliminate fractions. Okay, so trying to eliminate fractions. No fractions. Okay, it doesn't always happen, but that's what we're trying to do. Now, the first part of this lesson, math fans, it seems like it is, you know, you don't really know where to stop. You know, if I tell you to simplify, well, how do you know where to simplify it? I mean, if I gave you a fraction like 3/6, you know to simplify it at, you know, 1/2. All right? So that's, you know, it's a little difficult right now, but in a couple days we're not going to be doing that anymore. What we're going to be doing instead is I'm going to give you both sides, and you have to make it look like one of the other sides. All right, so let's just do a bunch of examples here. If I give you tangent of theta, cosine of theta, and I ask you to simplify that. Okay, well, what you do is you change that into sine of theta over cosine of theta times cosine of theta. That would cancel, and you wind up with just sine of theta. Right? Pretty easy. Okay, let's do another example. 1 minus sine of theta, 1 plus sine of theta. Well, what are you going to do? You're going to FOIL it out, of course, right? So I get 1 plus sine of theta minus sine of theta minus sine squared of theta. So these guys cancel out, and I get 1 minus sine squared of theta. Now, I'll tell you, math fans, not a bad idea is to start having those identities memorized or write them out. So if I said sine squared of theta plus cosine squared of theta equals 1, how can I manipulate 1 minus sine squared? Well, can't I just subtract sine squared? And so I get cosine squared of theta. Okay, so we've just simplified that to cosine squared of theta. Okay? And again, tomorrow, or in a day or so, you're going to be given a function, and you're going to have to figure out what it's, you know, prove that it equals one side equals the other side. Okay? Let's try another example. Here we get sine of theta times secant of theta. Okay, well, turn in the sines and cosines. Sine of theta times 1 over cosine of theta. That's sine of theta over cosine of theta, which is tangent of theta. That's pretty easy. All right. Let's do 1 minus cosine squared of theta over 1 plus tangent squared of theta. Now, the deal is, you're just learning these identities, math fans. So sine squared of theta plus cosine squared of theta equals 1. Tangent squared of theta plus 1 equals secant squared of theta. And cotangent squared of theta plus 1 equals cosecant squared of theta. Okay. So these are, again, your nice little identities, Pythagorean identities. And what you want to do is try to manipulate these to have them look like, especially when you see a 1 and a cosine squared, or a 1 and a sine squared, or a 1 and a tangent squared. Okay, basically you have two terms there, and you're trying to manipulate those two terms to see if you can get something to look like, or you're manipulating these guys right here to see if you can get it to look like one of those to substitute that in, and substitute only one term in. Well, 1 minus cosine squared, isn't that, if I take this guy right here, if I take that one, can't I just subtract sine squared? So isn't it cosine squared of theta equals 1 minus sine squared of theta? Okay, so I can rewrite that as sine squared of theta. And 1 plus tangent, well, that's given. That's the this guy right here. And so that's just secant squared of theta. Now what do? Sines and cosines. That's what you got to do. So we're going to do sine squared of theta over 1 over cosine squared of theta. So I can write sine squared of theta over 1, or over 1 time, and then it's divided by that value. Do you guys agree with that? So it's times the reciprocal. Okay, and then so my answer is going to be sine squared of theta cosine squared of theta, and that's it. That's your answer. All right, let's do a couple more here. 1 plus cotangent squared of theta over 1 minus cosine squared of theta. Well, both of these are identities. What's 1 plus cotangent squared of theta? Isn't that cosecant squared of theta? And 1 minus cosine, that's a little harder, so let's write out here. One minus just means I subtract this over, and that's equal to sine squared. So sine squared of theta. Okay, right in terms of sines and cosines, so it's 1 over sine squared of theta over sine squared of theta. Now it's really easy, and a lot of people like to go, oh cool, that just cancels out. And they like to put 1. But you need to realize it's 1 over sine squared of theta times the reciprocal of that. Okay, so that's actually 1 over sine to the 4th of theta. But remember I told you, no fractions. What's 1 over sine? Isn't that just cosecant? So it's cosecant to the 4th of theta. And that's your answer. Okay, 2 more here. These are pretty mellow. Cosine of negative theta over cosine squared of theta. Well, there you go, man. Cos is pos, so that's just equal to cosine of theta over cosine squared of theta. So the squared cancels out with that. I have 1 over cosine of theta. Of course, no fractions, so we're just going to do secant, or just secant of theta. Okay, and last example is going to be cosine squared of theta plus cotangent squared of theta plus sine squared of theta, and you got to simplify that. Now what you ought to do is you should recognize, hey, there we go, I got an identity right off the bat. So sine squared plus cosine squared is 1, so it's 1 plus cotangent squared of theta. Okay, and that's another identity too. That's equal to cosecant squared of theta. Alright, so that was a lot of stuff, a lot of examples here, and hope you guys learned something for all these identities. Alright, make sure you memorize. You need to know the Pythagorean identities. You need to know the negative angle identities, and of course, you already know the reciprocal and sine over cosine, cosine over sine for tangent and cotangent. All right, so you already know those, but make sure you know those other identities too. All right, math fans, have a nice day. Goodbye.